All right, so this is the 9th module. We're out of 10. So just a reminder, the Academy is designed as an interactive experience to give anyone the ability to successfully determine and solve safety issues on the roadway. We're talking about understanding our mission, understand how to find and use data, our top 3 emphasis areas, and solve top 3 emphasis areas. Speed management isn't necessarily identified as a top 3, but it is a cross-cutting measure. And then next week, we're going to demonstrate mastery by fixing an actual project. If we look at our roadmap, we've gone all the way through, like I said, all the basics of learning how to solve safety issues, get our crash data, perform the evaluation. We've gone through intersection, bike ped, and lane departure safety. We are now on speed calming and speed management. Safety field reviews will be at 10 o'clock this morning. And then the safety evaluation workshop is next week. Very excited, looking forward to seeing all of you and putting all of us together. So today we're going to understand talk a little bit about like signal timing and signal progression using operational strategies, looking at what design features can be utilized, what traffic calming features, what the FDOT Design Manual allows and encourages, and then we've got a few example projects to go through. So just a reminder, safety starts with design. We can anticipate behavior and consequences and be proactive. But barring that, we can also add countermeasures in later. The ideal, though, is making sure that by design, the roadway works with what the surrounding area is, right? It's not agnostic to the surrounding area. We can identify the users that are out there. We can identify how the roadway and the community are interacting with each other. And then those are our inputs for our design that then when we make our design decisions and our operational decisions, we have those in mind. So why does speed matter so much? To begin with, it drastically increases the severity of a crash if it happens, and the probability. So when travel speed increases by 1%, the injury crash rate increases by 2%, the serious injury crash rate by 3%, and the fatal crash rate increases by about 4%. That's 1% increase, right? So, we're looking at if you're going 60, if you're going say 30 miles an hour, 1% isn't very much, right? So looking at how serious that is, the difference between, let's say, 30 and 35 miles an hour, there's a very drastic increase in crash rates. I think you saw something similar to this yesterday, but I think that illustrates the point. At 20 miles an hour, 9 out of 10 pedestrians survive. But then once you get up to 40 miles an hour, only 1 out of 10 pedestrians survives. So if we think about our C3 areas, right? The C3 areas are identified largely as some of our worst pedestrian vehicular conflict areas, because it's kind of like suburbia, right? It's where we have high activity zones interacting with a roadway that a lot of times is kind of a through roadway. And how many of those roadways are set with a posted speed less than 30 miles an hour? So when we consider that it's an area that's generally not less than 30 miles an hour, and that also has reasonably high pedestrian activity, you're looking at a 50-50 survivability rate. There's an idea in a few other countries called the injury minimization technique for setting speeds. And a lot of that is looking at what crash types do we expect to happen on the corridor. And based off of those crash types and the survivability of those crash types, that's what the speed should be. Very interesting process, a little bit different than what we do here. But it is something to keep in mind when we start looking at things like that. And then when we look at vehicle on vehicle, right? As we notice with pedestrians, it's not a linear curve. The chance of severe injury spikes pretty significantly at some point. The same thing happens with vehicular injuries. So with head-on crashes, you're looking at a 43 miles an hour, right? Side impact 31 miles an hour. That's not a lot. Like when we look at what we think of the scale of acceptable speeds are in state roadways, it starts to put that into different perspective, because it starts to say, okay, hey, that scale of death drastically increases as soon as we get above, say, 30 miles an hour. With this side impact and pedestrians, we're looking at 20 miles an hour, right? And putting that into perspective, it's something that we can see our idea of what an acceptable speed limit, if we're looking at the risk for certain crash types starts to drastically change. And kind of, we're going to go over a little bit of what was done yesterday as well, but your cone of vision and speed at 25 miles an hour and 45 miles an hour starts to change. So when we talked about, I mentioned this in one of our previous examples, I've seen a tendency where people say, okay, well, there's drunk driving or pedestrians under the influence. There's nothing that we can do about it. But there is, right? So if you have pedestrians that are not acting responsibly, lowering speed still helps with that, right? Helps the driver be able to see that, say, someone's encroaching on the right of way. That's like when I'm sure you've all seen the PSAs about like parked cars and slowing down when kids are around, right? Because kids can dart out. So we know that we can design around a behavior. We can design, choose a speed that people can go that is safe for people making bad decisions. It shouldn't be a death penalty if someone makes a bad decision, right? So if a pedestrian does make a poor decision, if they are under the influence, it's not, the penalty for that should not be as significant. We've all made bad decisions in our lives. If we were in that situation, any other part of our life, I don't know that we'd be willing to accept those consequences. So just keeping in mind that there is the ability to design around those flaws, right? And that goes back to that safe system and that target zero, vision zero approach of understanding that we all make mistakes, the penalty should might be death, and that lowering speed helps with that. It's one of those options. Once again, your cone of, just illustrating again what you'd be seeing. And it's not that you're not seeing those things out of your periphery. You do see those things out of your periphery, but your focus changes. Like where your eyes are traveling and what you can actually focus on and look at and process is what's actually changing. Then when we look, like once we identify something, right? Like here's an issue. How does that affect what we do after that? And braking distance and speed, right? So the difference between 35 and 45 miles an hour is an additional 110 feet. That can be fairly significant. There's a lot of times, I think, with severe injury and fatalities, there's a difference of just like half a second, and whether that's severe injury fatality or whether it's property damage only or a minor injury, right? Because if you're thinking, with the pedestrian, obviously it's missing the pedestrian. But if we think about vehicular crashes, how many times somebody has pulled out in front of you and you've had to slam on the brakes to keep from hitting them? Even if you were to hit them, there's a difference between hitting on the driver's side door and hitting on the rear quarter panel of a vehicle. One is right on the person, likely to lead to severe injury or death, and the other is something that's minor injury or property damage. Something to consider as well, using the pedestrian example, is if you're going 35 miles an hour and you are able to hit the brakes, it's the impact speed, right? So if you are able to observe it, you're able to slow, having that still allows you the time to slow your impact. So maybe it's a 15 mile an hour collision instead of a 35 mile an hour collision. And if you were going 45 miles an hour, maybe that would be up to 25 miles an hour. And you start getting in that, 1 in 10, 2 in 10 pedestrians start to die. So even if it's not a perfect stop, understanding that not only does it let you see further and understand what's going on around the roadway, react better, the penalties are less severe, and it gives you the opportunity to also react and make better decisions to someone else's poor decision. Finally, we talk about barrier to crossing. This is still getting into the braking distance, but we kind of had the conversation a little bit with pedestrians of roadways going through communities. Sometimes there's not a better option for someone, and we were looking at the root cause and like societal characteristics. We identified there were certain characteristics of a population, certain demographics that they had twice as, if you had 4 of the features versus I think 2 of the features, you had 4 times as likely to be in a fatal crash. That's significant. And when you consider that, let's say like 0 car households, they have to walk. So when you're in Florida and you're trying to get from one side of the road to the other, if I'm in a vehicle, I'm air conditioned. I'm sitting on a comfy seat. I have a podcast or the radio on. Um, it doesn't affect me a lot to wait a little bit longer, other than my arrival time, right? If I'm a pedestrian, however, and I have to go the same distance, let's say it's a quarter mile, it's going to take me significantly longer to go a quarter mile than it is in my vehicle. And while I'm doing that, I'm in Florida weather. And then let's say I want to cross the road, I'm waiting another couple minutes for the signal to change. I'm exposed. If it's raining, I have to deal with that. So you go from when we're looking at the barrier, you go from 30 seconds to a minute with a vehicle to go quarter mile and come back to something that's 10, 15, 20 minutes for a pedestrian. Uh, so that's the reason why a lot of people just cross, right? And like as we observed, it is legal. Um, but the speed of the vehicles provides that barrier to crossing as well. So you start looking at what's an acceptable gap and how people can judge, and what speed increases, it becomes harder to judge. Not only is it a safety issue, but it starts making a mobility issue as well, because of that barrier to crossing for the pedestrians. And then something else interesting, we were working on an NCHRP about yield rates and marked crosswalks and looking to see if the type of markings make a difference. So we looked at basic crosswalks, and then we also looked at high visibility crosswalks, zebra style, ladder style. There's a number of different styles, and that was part of the conversation too. Is does the high visibility markings matter? And it does. You can see here the solid line is the basic crosswalk, and the dashed line is the high visibility crosswalk. So there is definitely a difference in yielding behavior based on the type of crosswalk there. What was interesting though is that we also found, as a consequence of the investigation, that the yield rate by speed significantly changes. So when we had the conversation about vehicles yielding to pedestrians, there is a significant difference in vehicle yield rate to pedestrians based on speed. So at 15 miles an hour, we had about a 90% yield rate of vehicles to pedestrians in crosswalks. At 40 miles an hour, that's about a 5% yield rate. So we see very significant changes there based on speed as well. Florida speeding related deaths, for the 2012 to 2021, almost 30,000 fatalities. In Florida, and 11% were speeding related. And that's where if you remember back to crash data, it's contingent on how well the officer does his investigation. Think about the fact that we don't always have data on how fast someone was going. The officer's making a judgment based on what witnesses say, what they can see, maybe from skid distance, certain things like that. That number is likely to be a lot higher, and that's also speeding related, not necessarily speed related. So if we think that's people going over the posted speed, that's not addressing whether the posted speed was appropriate for the area. And then when we take some of the data out of a strategic highway safety plan, 39% of speeding and aggressive driving fatalities involved unrestrained occupants. So not only do you have some of the aggressive speeding behavior with speeds, it's a lot of times it's also combined with other behaviors as well that add into it. Managing speed by design. So quick stop there. What does someone think is an appropriate speed for like a C3R, C3C context area? Can someone tell me that? There is a way to cheat. It's in the FDM. Lori?
I may be wrong. I think 45 or 50. Is that correct?
35 to 55. Brad got it.
Oh, okay.
Yeah. So, and when in the C3 areas, we'll talk about this later, they generally, you're supposed to start at the bottom and then justify a higher speed, right? Because we're acknowledging that those conflicts do exist, and we're trying to address it with our speed, and make a difference in that. So going into design, right? There are 4 different types of speed. There's design speed, operating speed, target speed, and posted speed. And want to understand this, right? So design speed is the selected speed used to determine roadway geometric elements. So if we're designing the roadway, what our clear, a lot of it's what our clear zones are, right? But it's the elements of in the FDM that are saying, hey, if you're at this speed, this is what the design element needs to be. This is what the criteria you need to meet is. That's your design speed. It's something that is chosen. The operating speed is what the people on the roadway are actually traveling at. So if you went out and did a speed study and you said, hey, 85% of the people out here are traveling 45 miles an hour, that's your operating speed. Your target speed is the speed at which you say, this is what this roadway needs to be at. Like, we don't want to rely on what everybody thinks it needs, what everybody thinks they should be traveling in the public. We want to say that, hey, based off of the characteristics of this roadway, this is the safe speed and what people should be traveling at. And then the posted speed is what is actually put out on the corridor as direction to the traveling public. Ideally, all of these will align. So this is an important concept to get. Is there anyone that has any questions on that concept? Lori?
And is it like I found out that previously the posted speed, no, design speed was 5 miles per hour higher than the posted speed, and then now it's the same. It's supposed to be the same. Is that a universal thing I mean, if that's the case in FDOT, but in other states, and is that correct?
I can't speak for every state. What I can say is that so we worked with a panel of, I want to say it's 10 or 15 different folks. Not everyone was as participative, but of other state engineers recently writing speed setting guidance for FHWA. And what I will say about Florida's philosophy on speed is more progressive than a lot of the country. There are a few areas that are a bit more aggressive with us on making sure speeds are lowered, of kind of like, we don't really care what everybody's traveling. This is what's safe, so this is what we're going to do, period. But the majority of the country is really still using the 85th percentile. And they're still looking at that design speed needs to be above the posted speed so that we make sure we have a buffer if people are going faster, right? But that's also a self-fulfilling prophecy, because if we design it to go faster, people generally will go faster. We felt that it was pretty successful. One of the things we introduced in the guide is the idea of target speed, because even though it's that conversation that's been going around in Florida for a while in FDOT, we found that the rest of the country isn't talking about it quite as much. There are, like I said, there's pockets that are, but by and large, our impression was that just getting the idea that we need to be designing to a certain speed instead of putting a roadway out there and accepting what people travel it as, we felt that was a pretty substantial idea to be able to introduce to the rest of the country. So I will say, like, Florida is doing really well in that respect. All right. Train?
Good morning, everyone. I have the question right here. When the target speed introduced to Florida maybe years ago, when we review the target speed, with our team, we call it initial target speed, or with the other group, we set up the target speed for every project. So normally it's like you said, our group told me to make the roadway safe for all roadway user, right? So we tend to lower the speed compared with kind of like even the posted speed. We rely on that, but sometimes if we see something, we tend to lower the target speed. Tend to, not every single quarter we can do that. On the other hand, when we go to designs, like you said, design want to accommodate the faster the operating speed. So I'm kind of confused, like our job to make it safer, And then if go to design and you guys want, not you guys, I'm sorry, we tend to put the design speed, like higher than process speed. So and then at the end of the day, we would like to unify, view one number for all for those three, right? So I don't know if you have any experience or anything that you can share regarding to that kind of, to me, is conflict with different stage. Target speed we normally do in planning, and when we go design is, of course, I know that we have the team to identify those, but normally we don't just lower the design speed
So
as the way we do for the target speed. So I don't know when we
Yes.
can achieve that goal. Even with the multiple projects along the way, but I don't know when we can achieve that without truly understand what we want to achieve. Make the driver go to wherever they go faster, or make them drive safer.
So I think there's a number of things that are happening there, right? So like one is measures of effectiveness, right? Like it takes a while. Like state roads, I remember when I joined FDOT, like my mentality was, why are we worried about what's around the road? The goal is to get people from point A to point B. And that changed pretty significantly because when I compare my desire to have a quick commute versus someone else's desire to get home that evening,
Right.
the other person's desire, I think, ranks quite a bit higher than mine. Expediency versus survival, right? But it does take a while, especially when we have so many of our MOEs that are oriented around, our measures of effectiveness that are oriented around travel times, delay, things like that. There's also a level of comfort, I think, in the department because we're still learning about speeds, and how to lower them. If I as an engineer design this roadway a certain way, I can be liable if something happens. So if we design it, if we say, hey, the design speed's going to be 35 miles an hour, when we know everyone's traveling 45 miles an hour and somebody gets hurt and they sue, is that going to be an issue? I think every district has a different appetite for different things. There's big differences sometimes regionally. And I see Lois commenting on something I was going to say as well, is my impression is that target speed tends to be an iterative approach. So you have the ideal target, but it depends on how much you can incorporate into that project to do. So if you're doing a 3R project, and you don't have much that you can do except maybe narrow some lanes or something else like that, that's not something that you would be overly successful, say, lowering the speed limit by 10 miles an hour, going from a 45 to a 35. You could try a 5-mile-an-hour jump, but I don't know that you would get that. Reconstructing the roadway is a lot easier to do, I think, because if you're doing a full reconstruction or a new alignment, then that's something to where you should be budgeting from the beginning to make the roadway right. I see that struggle similar to what, like, say you see with traffic operations and speed setting, and that's one of the things like the MUTCD is addressing right now, and then the TEM is going to be addressing as well. The TEM is following the MUTCD. The MUTCD is setting up a 6-factor guideline for speed setting, where it does not say to use the 85th percentile, but that it says it gives a number of things, and that's only one factor. There's 6 other factors, other than including previous studies that don't touch on what operating speeds are necessarily, because we need to tell people what a safe speed is. You still see an attachment to the 85th percentile, though. It just takes a while to kind of get through, and that's where you see, say, the TEM is going to be allowing the 50th percentile, for instance. And I think some of those operating speed understandings, not just for speed setting, helps with design speed as well. Because when you're looking at the speed data, when you're making the decisions of what the design speed should be, and you're taking in the operating speed and the target speed, like what part of the operating speed are you looking at, right? Are you looking at the 85th percentile? Are you looking at the 10-mile-an-hour pace? Are you looking at the 50th percentile? Because if we're looking at the 85th percentile, for instance, that's going to iteratively drive the speed, the design speeds and the posted speeds up as you go. Because what you're doing is you're taking the absolute fastest drivers and basing everything off of that. I saw a thumbs up. Did that answer your question?
Yes, is the absolutely like what I'm having in my mind too. You know, like we consider the operation speed when we decide the design speed, and though people tend to drive faster, you know, you have the posted speed. Most of them going to drive over the posted speed, and if we design, just my thoughts share with, because I see designs here too. Just my thought, you know, if you design the roadway that's, you know, kind of like you said, support the operational speed, is it definitely at some point we need to really look at that to see if that's the way we want to move forward. Because I only involved in the target speed, you know, with the group, and we have a good discussion on how we can set the target speed that kind of like meet our needs, move people faster, and make them safer. You know, so but thanks for
instead of
information.
moving faster, I would look at travel time reliability. And one of the reasons why is when we look at our measures, like if we follow what and I think it's an important conversation, so I'll spend some time on it. And Lois, I think you, Brenda was telling me you've got some good input on this as well, so feel free to chime in. But when you look at like our capacity measures and our level of service measures, Florida is continuing to grow, and we're growing very, very quickly. So especially with D4 being in an urban area, what is your solution for maintaining your measures? Right? So if we think through that and what's going to happen as we continue to grow and we're trying to maintain that measures, can we physically expand the roadway enough to accommodate everyone? Right? We could increase the speeds, but theoretically, but then you still have intersections to deal with. And when you're dealing with signalized intersections in urban areas, there's only so much time you can allocate to any one direction or any one movement. So that's when we start say like, hey, can we, the way we are currently doing things, will we be able to meet our measures in 20 years from now, right? In an urban area, you're not going to be widening. There's not very many new alignments that you're going to do. It's more in the rural and suburban areas that you're going to be able to do that. So then when we're making our decisions, and we talked about this in a few modules ago, it's based on our priorities. If we know that we're going to fail these priorities, what can we do? Is that, you know, lifestyle, like helping with community health? Is that health on the roadway, travel time, going back into that, say, travel time reliability? It starts getting into transit ideas. There's other things going on with that. Once we start accepting that the tools we used to use to meet our measures are starting to disappear as we continue to grow and urbanize. Do these operational speed studies assign any weight to the types of vehicles operating on the roadways or overall road users' operational speed? I assume you're talking about like trucks.
Yeah. Do we say, hey, you know, I mean, the road is supposed to be for all users, including freight. I was wondering if there is a preference, if it's like a more residential area, then.
So I guess I'll turn this back on you then. How would you accommodate freight with operational speed when you're doing operational speed studies?
Ask me. I
Mhm.
I have to say I don't know.
Yeah, the traffic operation normally do that one, right? Everyone, please correct me if I'm wrong. But you know, we normally have, I think they have multiple techniques or method to measure the operating speed. But I'm not so sure unless someone in the operation can tell us now.
But
Maybe Brad know that.
what I'm getting at though is choosing a safe target speed. Does that negatively affect freight users?
Can you repeat your question again?
Does choosing a safe target speed negatively affect freight users?
I would think yes. For if you talk about the truck, right?
In what way?
You know, the main purpose of truck is moving goods, and I think the travel times is very important for them. And to be honest with you, if some unsafe issue, you know, if the crash something happen, people in smaller vehicle take more consequences. Just my thought, you know. So lower the target speed. That's why, you know, we have the facility where we can accommodate, you know, trucks even more. We have different threshold for that, which is much higher than the other roadway system, right? So I think we did look into the benefits for the trucks. It means like we don't lower at the way we lower for, you know, like different roadway system. The cities have different set of target speed. But if you ask me if they like it or not, you know, not necessarily they like to lower the speed.
True.
Yeah.
So yes, FDOT accommodates freight movement through the SIS facilities, which have a higher speed generally. As opposed to making the trade-offs, I think it depends. It goes back to what your priorities are. Are your priorities faster throughput, or your priorities safety and health of the community? And then it goes back to the discussion too, and I know this discussion happened a lot when context was starting to be introduced, is who has a greater priority, the people traveling through a roadway in their car or the people that live there? And that was part of the debate at that time. And I think what we have largely come to, whether I'm not saying everybody is on board with it, but still like what the state has come to is, since we're going to design by context, we're acknowledging, since everything is context based at this point, we're acknowledging that the people that live there and are using the roadway have a higher priority than the people that are traveling through an area. So I think that the simple answer is it depends, right? There is some, I think, acknowledgement, and yes, Robert, we do set a target speed on SIS facilities. SIS, though, when we get to the FDM, there is a difference in how much you can lower the speed. I lost my train of thought. So what we've acknowledged is that the people there generally have a higher priority than the people that are just traveling through, because the people that live there are also using the roadway as well. And when we consider percentage of users and where it's going, it makes more sense to stick with safety and community health as opposed to pure throughput. Getting into that a little bit, the next few slides do talk about that a little bit. You're familiar now with the context classification. C3 and C4 have the most roadway miles, but also the highest crash rates. And this is kind of getting into the question Lori posed: who are our users, and how, and what are we looking at with users? And we can see too that as we start to get into more urbanized more the urbanized contexts, the vehicles and the users that are showing up start to change, or should start to change, right? So we have an idea usually that, you know, we need to accommodate a WB 62 everywhere, one of the largest trucks. And that's what industry currently does a lot of, because that's what exists. But I think, you know, it doesn't always make sense, right? Like, we're not necessarily, like, with freight, there's different ways we move things, right? For long haul distances, we're looking at shipping, we're looking at air freight, and we're looking at trains. There are over-the-road truckers, but when you look at the vast majority, it's through some of those other things. And then it gets to a distribution center, and then it gets on larger trucks, and those trucks take it somewhere else. And sometimes it's the final destination. Sometimes it's put on more smaller panel trucks. So it's looking at who is using it as part of that context analysis for what our appropriate speeds need to be. And then hitting on the SIS facilities, here's the allowable speed ranges in the FDM based on the context, and then the allowable minimum speed based off of the SIS facilities. So there is a caveat that the SIS minimum design speed can be reduced past that a good bit. You can go to 35 miles an hour for C2Ts, 45 for curved roadways within NC3s. And then you can go to 30 miles an hour for C2Ts, C3s, and C4s for facilities with a transit route. So you're still seeing that acknowledgement that, hey, once you start adding in more vulnerable users, more vulnerable contexts, even the SIS starts to drop off. What we're seeing is, and it's a mindset shift, right? I've seen it. See, I joined the department in 2010. So I have seen a massive shift in the department's mindset from when I joined and all the old hats were there to today, when we're sitting there, we're having the conversations about like, what are our highest priorities? Should we be changing? Like, maybe we shouldn't be doing peak hour design. Maybe we should be doing a different design factor. Maybe we should not be looking at the 85th percentile. We should be looking at the 50th percentile. There's a lot of changes where we're going through and saying, hey, this old information that we're using isn't really working for us. Let's change what we're doing and look at different goals. Lois?
You know, as you bring this up, I think one thing about those design speed ranges, one really good thing about how FDOT's implemented complete streets, including context classification, has been kind of an ethic of we're going to be flexible and we're going to use common sense. So an example of C1, C2, where that design speed range is very high. We had a bridge replacement project, Sebastian Inlet Bridge Replacement Project, and D4, D5 had context classifications on A1A by that bridge of C1 conservation in D4 and C2 rural or sparsely developed in D5, and it made sense based on the criteria in the FDOT context classification guide. The designer said, hey, there are a lot of pedestrians and bicyclists around here because there's a state park. So can it be some other context classification? The answer was, you don't change the context classification, you need to get a variation to the speed to match the circumstances there. So there's learning going on in all sorts of directions here. So maybe there are different categories of conservation design speed ranges. Who knows where it will go? But I just throw that out as variations, exceptions are another part of the picture.
That's a really good point. Because right, and it goes like the standards are a box of crayons, right? It goes back to that substantive versus nominal design, nominal safety. It's a starting point, not necessarily your ending point. It's something to note on context as well. Context is very simplified. So Patty Hurd with Kittleson is largely wrote the context classification guide. And identified, like, she's the one that broke down the stuff. We were talking the other day about it, and because there is Hillsborough County, we did a context classification effort with them, and they wanted a C3T. So it's an idea too that these are how we're trying to classify things. Not everything perfectly fits, right? So just being mindful of that. So the appropriate speeds, target speeds, you're going to look for the FDM consistency, and then you're going to look at the target, like that starting point for your target speed. So based off of your context, you're going to look at SIS facilities. And then once you get into that, you've got a flow chart here, right? So like, what's the roadway function? You're gonna look at significant design considerations, context surrounding the roadway, who are your users, what's the most appropriate target speed. Remember, we start at the bottom and work our way up for most of the contexts. C1 and C2, we start at the top and work our way down. Then we start talking about what features can be used to bring in. And we're going to do kind of an iterative cycle, right? Is this going to be sufficient to achieve the target speed? If it's not, add some more or change the target speed. If it is, move forward. It's not to overcomplicate it. It's looking at that area, and it's just making sure we have a good design that accommodates what our goals are. Excellent discussion. So I'd like to move forward into some of these, talk about some of the features that are outlined in the FDM before we start talking about some more. If you have any questions about these, let's pop them in the chat and we'll go through and we'll address it, and then we'll have time for Q&A after. What I will say is I did drop, I did want to mention in case someone didn't get it, it's about an hour-long presentation. It's it's a professor we've worked with in a few other areas on signal timing for context and for speed. Anyways, this video on using traffic signals to reduce speeding opportunities. District 1 has applied a lot of these principles and has found that on a lot of our corridors, you can significantly control speed using signals that have the key is enough density, using signals without any other speed management techniques. So trying some of the stuff you're talking about with trying to achieve those, if you're in an area that has a high enough signal density, you can control the speed. There's no question about it. All right. So what is speed calming? It's essentially identifying a number of speed features that are going to bring speeds down. Once again, there are other industries that design for the user. This is what this is. We're used to designing for the physics of driving a car, right? Or like our super elevation. We look at what the radius of the horizontal curve is. We look at the coefficient of friction. We look at what the comfort level of the driver is with whatever centripetal acceleration you're trying to resist, and then we achieve the slope, right? That's for the physics of driving a car. When we start to get into user design when we're looking at, say, signing and pavement marking, right? The user's perception reaction time, the ability to read and understand what a sign says at a certain speed determines like the lettering size, the placement of the sign, things like that. This is, if you think about civil engineering, this is more akin to, say, architecture or industrial engineering. And I bring that up to say that while it may not be something that we've thought about in the past, it's something that other disciplines do. So it is doable, it is achievable. It's something that we're still learning on, but it is something that there are people that design around the user experience all the time. I don't know if I ever used it in this class yet, but Disney, the difference between going to Disney versus going to one of any other theme park, let's say like Legoland or whatever else. Like, Disney knows how to move people. There's a science to it and it works. We just have to figure that out. So FDOT's philosophy goes around 3 factors: enclosure, engagement, and deflection. They're supposed to be used in conjunction. Singular speed treatments aren't generally effective. You want it combined in your approach. So enclosure is a sense that the roadway is an outside room rather than a limitless expanse of space. Like, you don't want it to look like a runway, for instance. You want it to feel like you're framed. It's not like a big warehouse that you're in. You go as fast as you can run as fast as you want. You want to be running through narrow hallways with a lot of people. Your sense of speed's enhanced because it gives you more of a frame of reference. If you think about going through, say, I use US 17 a bit, or US 27, in the more rural areas, the C1s, the right-of-way is pushed way out. You've got multiple lanes. You can go as fast as you want and not even notice it, right? Whereas you start getting to something where trees are really close to your vehicle, you're starting to pay attention more on how fast you're going because that frame of reference is there. Engagement is the visual and audio input connecting the driver with the surrounding environment. We're insulated a lot in modern vehicles with modern suspension, insulation in the cabs. you're not getting a lot of impact or input from the surrounding environment other than what you can see with your eyes. What you're doing here is trying to make it to where the driver's having to interact with the environment. You've got to be conscious. You got to think about it. Textured pavement works. You think about driving on bricks or cobblestone. You definitely get feedback there. Florida has really, really good roads, and sometimes that can hurt with speed because it is very, very smooth. So it's introducing things in the roadway environment at the appropriate speed to further lower the speed, right? It's kind of like street trees. On-street parking is one of those things where you've got engagement, but you don't want on-street parking in a 70-mile-an-hour roadway. You want it in a 25, 30-mile-an-hour roadway, right? Like there's an appropriate time to do it to drop the speed further. And then deflection. Deflection's pretty easy. It's either horizontal or vertical, and it's something to where you cannot physically drive this fast without losing control of your vehicle. It's one of the reasons why roundabouts become so popular. So when we're looking at identifying strategies, we take our context classification and the transportation characteristics, and that's going to lead us to our roadway users, the regional and local travel demand, challenges and opportunities for each roadway user. How are people using the roadway? What features can we give them? What are the unique challenges when they're working through that? Then we're going to take the next step with community. Like, what's the vision of the community and study area? Like, what are they trying to achieve there? I know District 1 has the planning studios, and that's a lot of what they do is say, hey, this is what we want to achieve. We are looking at doing a mixed use area here, or hey, there are some areas that say, hey, this is going to be our industrial area. We just want to get people to the next major roadway. Who's the major road users, and what is the desired role of the facility? So we get into the design manual, chapter 126. We talk about lane repurposing. Something to keep in mind with lane repurposing, recent legislation has modified the outreach requirements and a few other things. So just being aware that if you're getting into that, knowing what the most recent rules are. Context-based design, design controls, and speed management is chapter 202. Lane repurposing projects are a very strong tool for speed management. Because it's kind of like doing a rebuild. Like if you go to PD&E and you're doing a major widening, you're completely changing the character of the roadway. Lane repurposing is the same way. You're changing the character of the roadway. And one of the benefits of lane repurposing is that the additional space that you achieve by removing a lane and reallocating to something else can be used for other speed management strategies. Context-based design. Essentially that, identifying the context and changing what's happening on the roadway based on that surrounding area. You got your design controls, and the speed management, outlining enclosure, engagement, and deflection, as well as identifying what countermeasures can be used in which speeds, and going through a lot of the countermeasures we're going to talk about in a minute. Target speed. Once we said before, the target speed, post speed, design speed should all be the same, or speeds of 45 miles an hour or less. And there's some direction on changing that design speed to match the target speed. One thing is when we're talking about speeds, the district design engineer and the district traffic operations engineer jointly approve the selected speeds. They're supposed to be involved to the point that if after a project is built, if it's discovered that the operating speeds are requiring the design speed, or let's say requiring a posted speed higher than the design speed, traffic operations is supposed to write a variation on all the features in that roadway that do not meet the criteria based on the higher posted speed. So it's something to keep in mind. It shouldn't just be, I know we pound on design a lot. It's not just design conversation. It's a design, traffic ops, and planning conversation. Everyone's involved in it, and everyone has joint responsibility. So when we have that conversation of, hey, DDE and the DTOE are signing off and saying, yes, this is what we can achieve, both houses need to be working on strategies to achieve that speed. It's not just on one group within the department that works on that. So looking at the design manual, this is what we were talking about earlier. You have your context, you have your allowable speed, And then we have strategies to achieve it. They kind of go through, they'll say, hey, C above plus, look at that, like C2T at 30 miles an hour. You can use all the techniques identified from 35 to 45, but then you can also add in chicaning and islands and curve sections. So if we look at a C4 context, right, using another example, it's urban general, your target speed is 35 miles an hour. In this case, you'd be able to look at roundabouts, lane narrowing, horizontal deflection, speed feedback signs, RRFBs and PHBs, as well as on-street parking, street trees, short blocks, islands at crossings, bulbs outs, terminated vista, and road diets. You can see in here, well, we've had that conversation of some things can be safety hazards at some speeds, but safety features at others. It's a targeted, deliberate, iterative approach where as you go lower, there's more tools that you can bring into play to get lower and lower speeds. My opinion is if you're trying to do a really big jump in speed, you're looking at 10 miles an hour plus, to make sure you have enough features in the project that the roadway feels different when you're going through it. It's not the same roadway with a few unique differences. It's something that when drivers go through, they're like, wow, they really did something here. So we're going to get into a lot of the countermeasures. The idea with this is just to introduce them if you haven't seen them before. And then, like I said, once we get to the end, we'll start opening up for discussion about individual ones. So roundabouts we're probably all familiar with. It's effective. It's very effective as a transition from higher speeds to lower speeds. If you have more rural area or coming into something more suburban or urban, introducing a roundabout helps with that immediate transition to a lower speed. On-street parking. Chicaning. Chicaning can be used, it's shown on a 2-lane roadway. There was on Cortez, I think in Manatee County, chicaning used on a 6-lane roadway. It was highly effective in reducing the fatal and severe injury crashes on that roadway. So don't just think that it's only like a small neighborhood roadway. This is something that can be used on very large roadways as well. Lane narrowing, taking lane width to give to say other treatments, but also to kind of squeeze users in. Keep in mind your freight percentage. If you have a high truck percentage, it can be difficult to, maybe not safe to do it. One strategy is leaving a larger outside lane sometimes for freight to stay in and smaller inside lanes. Horizontal deflection. Basically anything, chicaning is a form of horizontal deflection. It's just anything that requires the driver to physically move their car to the side to stay in their lane. Street trees, very good at forming a sense of enclosure. Short blocks. So this doesn't necessarily have to be a street network, right? Going back to that Cortez project, there wasn't necessarily a roadway network there. But they put, where every chicane changed directions, they put PHBs there. So they use PHBs as a way to break up the block sections. So think outside the block, the block on this one. Vertical deflection. Essentially, if you don't want to jump your car, you're going to have to slow down and go a certain speed. These are for lower speeds, though. Only design speeds 25 miles an hour or less. Raised crosswalks can be considered for design speeds of 30 miles an hour or less. Something to consider with this too is sometimes if you're coming to a stop condition, the other roadway may be a little bit faster, but if you are required to stop, so it's not a signalized intersection, let's say it's a 4-way stop or you're on a side street, being able to introduce them there as well. And the other thing that Lois pointed out, variations and exceptions exist. So if there is some extenuating circumstance, keep in mind that even though this is the standard, if you have good justification, you can always do a variation or exception. Speed feedback signs. These are slightly effective. It is sometimes questionable. I would not rely on these. These are a tool to be used with other things. I think a lot of times what they're doing is providing notice if you're not intending to speed that you might need to drop down and look at what's going on. Posted speed pavement marking. I believe District 5 is doing a study on this. Be interesting to see how effective it's proven to be. Lowering speeds and speed sign density. So there is justification. There are studies that have shown that arbitrarily lowering speed limits has had an effect on lowering speeds. They may still be speeding, but they're not speeding nearly as much as they would with higher posted speed. Curb extensions. So this is not only good for managing speeds, it's also good for helping pedestrians because you're shortening the crossing distance a pedestrian has to do. And if you are worried about operations, it helps with that as well because now there's not as much time that drivers have to accommodate a pedestrian being in the roadway. RFBs and PHBs, it creates engagement, and once again, it helps with establishing shorter block lengths. Terminated vista. This is eliminating the runway effect, where all you see is roadway. It's the idea that there's something right in front of me. I need to slow down. What's interesting is there's a roundabout on 33 in Deanstill Road. It's either a C1 or a C2 area. I'm not sure off the top of my head. There's a roundabout put there. It was a two-way stop. It was a two-way or four-way. There was a roundabout put there, and there's a lot of concern about it being out in the middle of nowhere. What's going to happen? It's worked very well. When we did analysis on it, the only people that have the severe injuries from that intersection have come from people that were falling asleep, which that's the reason why the intersection was looked at to begin with, is people falling asleep and not paying attention and T-boning people. Or people that are playing around. There's a lot of four-wheelers that go out there and decide they're going to play around on the roundabout and they end up hurting themselves. But by itself, aside from those issues that either already existed or is something else entirely, it's worked very well. And one of the things that it did is the chicaning approaching the roundabout, they put a breakaway sign, a double post breakaway sign, larger probably than what it needed to be. Showing which roadway goes which direction, right? They just advertising the roadways. But the idea is that when you chicane over, you're looking straight at that retroreflective sign and you realize you can't keep going. And then you end up following the curve through. So terminated vista is one of those things that you don't have to necessarily put a tree right in the middle of the roadway, but it is something that if you get creative, you can find ways to introduce it. The idea of transition zones, you don't want to immediately go from 60 miles an hour in a C2 to 30 miles an hour in a C2T. So you've got the perception that you have your rural zone, your transition zone, your community zone. Inside the transition zone, you have an area where you're starting to realize that, hey, there's something changing. Whether it's landscaping, whether it's a gateway feature like signage, but you're realizing there's something going on with the context. I'm getting into a more urbanized area, and then your deceleration zone where it's giving you that area to slow down and get to the appropriate speed before you get into the critical area. All right, so those are some of the main items we wanted to go over. Like I said, it's not a lot. There's a lot of information out there on speed management that we can find, but I wanted to give kind of as like I said, this is the basic safety academy. So I want to give a basic idea of what's out there and what's available to use. Are there any of those countermeasures that we would want further discussion on? Lori.
I don't know if this was specifically, maybe it was, like the center line hardening. Are there situations where there's, I guess, more uncertainty whether they would be safe to add in certain places like crosswalks or near, I don't know if it depends on speed, because you did mention that too.
I don't see any uncertainty with that. They should not be in the vehicle path, so they shouldn't be jutting out far enough that the opposing traffic is going to hit it. It's going to function exactly like a median section, any other curb section is. It's adjacent to the travel lane. The biggest thing, right, with center line hardening is it's forcing turning traffic to slow. So I guess if slowing turning traffic is less safe, maybe if there wasn't like a left turn lane for some reason, but it's usually used at signalized intersections. So you normally have something dedicated there. Sorry, I'm trying to think through it. And then there's also, even if it does increase rear ends, it goes back to that conflict point conversation, where what's the most severe conflict point, the pedestrian car interaction or a rear end crash. So I guess I would say I don't think there's any negative aspect to using centerline hardening. So can someone give me an example of, so let's say we're in a C3 area, just suburban context, and I'm not worried about, the exact design standard right now, but just we're trying to get 30 miles an hour. We have 45 miles an hour. We want to get to 30 miles an hour. Any ideas of what we can use to get there? So maybe an idea about deflection. Anybody have an idea on deflection?
I was
Raised crosswalks. Yeah. So we have raised crosswalks. Definitely, I think there's still a speed issue, but I think in the right places we could definitely do raised crosswalks.
Ball vaults.
Bull belts, yes. Chicanes, if you got the space. And if you don't have the space, what can you do? Lane repurposing. What about sense of engagement? How would we increase the sense? Lane narrowing would work as well. What about a sense of engagement? Like, how would we bring the person out of the mindset of it's only me and my car and engage with the roadway? I think speed bumps can work. I don't know that we put those as much on a state road. We do have transverse rumble strips, which are more of I think a tactile sound feature than it is necessarily a full-on speed bump. And those we use a lot heading into sensitive stops or curves to get people's attention. There's a good CMF for that on curves.
The reduced block spacing, like bringing more things to the peripheral so they're more aware of the things adjacent to them. I guess even the ball bops could work if you have those in more reduced spacing. They could be aware that there's pedestrians or the possibility of pedestrians.
I think so as well. And honestly, I'm glad you brought that up, because there's a project that I did in Lakeland once. We did a lot of PHBs, and the utilization of the PHBs in that area is horrible. No one uses them, but the safety has gone up. And the two things that we can think of are either it's that shorter block segment, or it's the fact that the presence of the PHBs makes the drivers more aware that there are pedestrians there and there are people interacting with the roadway other than themselves. So even if you don't get people engaging with the actual device, it can sometimes still be helpful. Trees along roads outside clear zone. Yeah, and if you think like with the clear zone too, if you're in the urban areas with low speed, and especially if you put curbing up, it gives you, your clear zones aren't very, very large. The trees are also good for that community health benefit outside of direct transportation impacts, just for the cooling effect that it has on the urban heat island. All right, so let's look at a case study. Oops, presence PHBs not only make drivers aware of pedestrians, but also reminds them they're supposed to yield to pedestrians. Absolutely. I think there's a lot of benefit in that. And then Lois said, partnership with local governments to control land use development and urban design. Yes. I will say that that's very good. Like I said, Planning Studios has done a lot of work with trying to work with local governments so that they can get all the codes, rules, regulations on their side. So like basically, let me back up. When they talk about the roadway vision, like the corridor vision plan of like, this is what in 30 years we want this roadway to look like and function like. And that's a conversation the locals have with DOT. That has previously been mostly only used by DOT in the sense of, okay, well, we'll make sure our plans align with what this vision is. Planning Studios is also working now with the locals to say, okay, here's an audit of what you have going on with your land use, your comp plans, everything else, to make sure that it's that you are doing your part to make sure it's in line with that vision as well. There are some struggles though. There are a number of state laws that restrict what locals can do sometimes. All right, so let's look at Rainier Avenue in South Seattle, Washington. It's not Florida. The design standards are a bit different, but some of the ideas of what they do are things that we can apply here. So this was the existing street layout, right? So we're seeing 4 through lanes with separated by striping and parking on one side of the roadway. The future layout looked at bus lanes / parking, depending on where it's at in the corridor, 2 lanes, and then a center turn lane. A lot of times going from that 4-lane to 3-lane conversion, it works out really, really well. Simply because when you take the turning movements out of traffic, it frees up the throughput. So if you are looking at if you have to look at some of the traditional metrics of level of service and stuff like that on the corridor, 4 to 3-lane conversions when you're doing a lane repurposing can work out exceptionally well. So they looked at a few other things, right? Not just the typical section. They looked at curb extensions. They added some vertical deflection, the way of raised crosswalks, school zone beacons. So that's some of that engagement, right? So it's looking at, hey, there's something else going on here. There's school zone. They did a lane repurposing, reduced the target speed. They did speed humps on this one. So speed humps is where you're not necessarily dealing with a raised crosswalk, but you're still putting vertical deflection in. ADA upgrades, and then added leading pedestrian intervals. It's kind of a bird's eye view of what's going on. So you got a corridor with 6 different main locations with stuff's going on. If you look at the Rainier and Graham Safe Routes to School, you're looking at raised crosswalks, the bus pavement, you're extending sidewalks, you're placing corner ramps, tightening up the radiuses, changing some of the access. Rainier and Holly, you're doing a lot of some of the same things. Like you're not rebuilding the roadway. You're changing parts of it. You're extending the sidewalk and bulbing it out. Widening crosswalks. You're changing signal timings. And still same thing here, right? Like you've got the new typical section, and you're changing signal timings and changing crosswalks. This is not, even though some of those we saw that huge list. And all of those things have their place in it. You're not rebuilding the roadway. You're taking what's normally like a C3, C4 roadway, and you're changing what it is. You're not necessarily moving curb line everywhere and making significant changes. So kind of going back to what we're doing, you're looking at 4 11-foot turn lanes and a 7-foot parking lane. The new cross section is 2 12-foot travel lanes, 1 12-foot center lane turn lane, and 2 8-foot parking lanes or bus lanes. Rainier South, you actually did squeeze it into 9-foot lanes. Just understand that's not Florida standard, but they did it. Looking at the other typical section as you continue through. And then when we look at the results, the posted speed was adjusted from 30 miles an hour down to 25 in conjunction with the other changes they're making. So if we look at your percentile speeds, you've got a 16% drop in the 50th percentile speeds northbound and a 10% change southbound, right? Your percentage speeding improved significantly as well. And your top end speeders, the drivers exceeding 40 miles an hour, there's an 80% reduction and a 72% reduction. So we see significant changes. There's a 52% decrease in speeding northbound, 28% decrease in speeding southbound. Ended up being a 15% decrease in overall injuries, a 30% decrease in overall crashes, 30% decrease in injuries, 40% decrease in pedestrian and bicycle crashes, and 0 fatal and severe injury crashes. So talking about something that's a little closer to home. So the Orange Blossom Trail. This does not have an after study with it yet. right now, a lot of this is what we want to talk about is things that can be done on state roads. So the part of it's to kind of talk about, it's a District 5 project, right? It's talking about what can be changed on a state road. Because I think sometimes and I've heard plenty of conversation of we can't do this, we can't do that. Trang, I think this might be talking to some of the conversation that you and I were having earlier. So what we have, this is the proposed layout. It's a 6-lane facility. We're going to be adding enhanced pavement markings, raised crosswalks, PHBs, increased landscaping. I believe there's pedestrian fencing as well. And then improved pedestrian lighting. And there's also in-roadway lighting with the project as well. I think you're using the in-roadway flashing RPMs when you're looking at the raised crosswalks. They added some lane narrowing with, sorry, I went too far. So the idea behind this one is you're taking like an urban suburban roadway, and they are putting vertical deflection, right? Like they're putting the decreased block sizes, the pedestrian hybrid beacons, with the issues they were having. I don't know that I would recommend pedestrian fencing everywhere. I'm not sure that it goes back to the other conversation of we need to make sure that if we're going to restrict people, we have adequate facilities. But they do here. They have a high frequency of crossings here to be able to restrict in between to help get some of that, I guess, compliance with the crossing. One thing to be careful with if you are ever considering the fencing is there are going to be some people that are going to cross anyway. Making sure there's enough space for them to stay out of traffic when they get there and realize that they may not be able to cross. But it's a good example, I think, of all the types of features that you are able to throw into an urban corridor and a state roadway. So this is the project I was talking about earlier, State Road 684 Cortez Road. So some of the FDM strategies, they looked at lane narrowing, horizontal deflection, landscaping, median islands, bulb outs, PHBs, and then they also added signal timing and right turn eliminations. The existing typical section was 6 12-foot lanes. Now we're looking at 4 10-foot lanes and the outside lanes being 11. Once again, I talked about a little bit about like making that outside lane a little bit larger for truck traffic. Maybe a little bit hard to see, but everywhere you see on this slide a PHB or an intersection is a different direction for chicaning. So they push them, they use the additional space to angle the travel lanes at the outside curb, then you hit a PHB and it angles to the median curb, and it goes back and forth throughout the corridor. Picture before and after. You can see just straight medians, and then in the picture to the right with the barrels, you can see where the difference between the yellow line of the edge of the travel lane and the median. It shows you what space that you're working with, you're able to accomplish and grab by doing the lane narrowing. And then right now there's good results. You know, you're looking at a 63% decrease in serious injury and fatal crashes, and all crashes were reduced by 20% on the corridor. What's interesting about this one is this one did get good pedestrian compliance. So there's actually a 91% compliance on this corridor with either marked crosswalks at the signalized intersections or utilizing the PHBs. I think I have one more case study, but I want to stop for a minute. I realize I've been going on for a little while. Any questions so far in the case studies or any ideas? Lori?
So what if there's already a project in process that has a typical section, and then there's opportunities for safety features? Are there any kind of expedited typical section approval processes?
Not that I'm aware of. That's something that you would have to work with the design team and where they're at with the process. There's a letting plan, but we like to stick to that. But at the same time, sometimes things can change. You know, I'm of the opinion that you can have a conversation about anything. All they can say is no. It may require funding. So, moving things around. I guess I come from so those of you that are not familiar with Secretary Nandom, Secretary Nandom does not hold work programs sacred. If it needs to be funded, he finds a way to fund it. So whether it's a lot of it involves moving projects around. I know our program management folks get a lot of headaches, especially in gaming, because of that. But and he always approaches it of do the right thing. So if it comes down to, hey, this is where we need it, we have this project and it's letting in the fourth quarter of this fiscal year and it needs to be pushed, he pushes it. So I guess I come from a little bit more aggressive funding background in that respect. And it does cause a lot of heartburn sometimes moving things around. Just there is pain attached to that, but it is possible a lot of times. It can involve difficult conversations with elected officials saying, I know we promised it here, but we need to move it here because of this. But there is possibilities. I would say have the conversation, just understand that it's not always clear cut. While it may be possible, it may also be that particular instance may be very painful. And that's why it's good to have ways to get in and screen projects while you're still in the scoping process. It's much, much easier to figure out what needs to be done in the scoping process than it is to tag in later with it goes with or something else. And that's another option too, is depending on when the construction letting is, let's for construction, it may be possible, it may not be possible to delay design, but it may be possible to push construction out. And if that's the case, and it's a significant change, I mean, there may be conversations about goes with projects to come in later to add stuff. So there's options. It's flexible. It just depends on flexibility, where it's at, and the circumstances around it.
Nathan, I would say in District 4, philosophy is very similar to District 1, or at least it has been over the last couple of years I've been involved in safety, that we've had those tough conversations, leadership level of, making adjustments as needed. And currently right now we're trying to add lighting to a project that's already been designed and probably doing, a safety funded, part of the FM or just throwing some money on there. So we're making those decisions at District 4, maybe historically. Sometimes we were more focused perhaps on dates and meeting commitments, but I've definitely heard from our leadership that they want us to escalate things to them, that if we need to consider safety and maybe back in the day we thought it was too little too late or something, we need to have those crucial conversations now. So it's great.
And I think some of the data that we have now too helps with those conversations, because in the past, does it have a certain historical crash pattern, right? Maybe it does, maybe it doesn't. And now we've got, say, the root cause analysis. We know more about the systemic analysis. We have the predictive methods. We're not talking about it in this course, but there's predictive methods to talk about stuff. There's a lot of information there. It's getting people in the room and having the conversation and building consensus for it. Lois?
Well, I think another part of this is the partnerships. Like Complete Streets implementation hasn't come with a new pot of money. And the idea was to coordinate with partners where you have an MPO that'll put money in for a repurposing with a resurfacing or something, or will allow you to do more with things by leveraging and combining resources. That takes effort, obviously, and people being on the same page, but it seems to be a part of this as well. What can partners contribute and how can we leverage our resources to maximum effect?
That's good conversation. And we can help them with that too sometimes, because sometimes we can have them fund it and have a payback and pay them back in an outer year if it's something that we want to do with flexible funding. We've done that with a few roundabouts where the locals really wanted it now, where we've had them fund it and build it, and then we've programmed a payback in like the 5th year of the work program. One thing too with the planning studio is that some of the conversation they've been having as well is when you're looking at the MPO and TPO, if you're coming up with your corridor vision plan and you want FDOT to do all of this, are your priorities aligned with that. And I think that's part of what you're going to add too as well, Lois, is, you know, are you putting your money where your mouth is? Are you expecting FDOT to do all of this and you're not doing it as well? So there's good conversation to be had, and partnerships to be made to maximize funding across the multiple sources. Any other questions so far? Carla?
Good morning. Just kind of to go back to your original question about the case studies, introducing a two-way left turn lane when there wasn't one before, would that not increase instances of head-on collisions? And where would that balance out with reducing potentially side swipes and rear ends from people trying to make those left turns in the middle of a through lane, and now you're potentially increasing head-ons if people are now coming in the same direction?
It gets into lower speeds, I think. And it's a good question, because when you get into 2A left turn lanes and 5 and 7 lane sections, they're a really bad idea, data driven. I don't know if I'm sure someone has studied at some point. When we used to do screenings for access management projects, we really never found, for whatever reason, we never really found issues with 3-lane sections. And maybe it's because of the context or the speed that most of them are found in. There were always really bad problems with 5 and 7 lane, but for whatever reason, 3-lane never seemed to have the same issues.
Oh,
I don't know that I can answer why though,
Okay.
other than maybe lower speeds.
Okay, thank you.
All right, we have one more case study and then a little bit about operations. So Golden, Colorado. So this location has a very similar issue that we have in a lot of our suburban areas, right? Posted speed 35 miles an hour. The 85th percentile was 48 miles an hour. You're looking at 4 crashes a month with at least 1 injury. If you look at the picture of the roadway, honestly, it could probably be many roadways in Florida. You have very, very wide travel area. You have minimum pedestrian accommodations and not much going on. It's very much a let's get you to point A to point B roadway with every driveway in between. They put in a modern roundabout section. So essentially like I guess it'd be like a U-turn corridor, right? So instead of necessarily making U-turns everywhere, they have some median openings and facilities for that, but it's a series of roundabouts, not just one to say slow speeds initially, but you're going to keep heading the roundabouts through the corridor. You put in narrow lanes using center medians. They restricted the left turns. As we see in this slide, there's absolutely no restriction. Putting in the median sections now, curb and gutter with sidewalks, put in a good separation between the pedestrians and the roadway. So not only does it help with safety, but there's a comfort factor as well. And they chose a 25 mile an hour target speed. End result is a 36% reduction in crashes a month and 97% reduction in injury crashes. Bike-related crashes went from 78 crashes over 5 years before to 4 crashes over 3.5 years after. They did have a reduction in delay. Wasn't significant, but there did exist. And then a reduction in the 85th percentile from 48 miles an hour to 33 miles an hour. So even if your posted speed is still under the operating speed, you're still going to see a reduction. And then finally, I know we talk mostly about design, but I am a really big fan of traffic operations with speed management, because it's, if you're looking at signal retiming, I think you're doing, what is it? You're retiming urban corridors every 3 years and rural every 5 or 1 in 3. But it's a very low cost effort that's already happening. And if you have the signal density, and that is one key, you got to have some of the signal density. But if you're doing that, you can make significant changes in the traveling speed on a corridor. So look at US 41 from Tel Aviv to Orlando Avenue. It was the highest fatality per mile section in District 1, 31 fatalities, 264 serious injuries in 5 years. Very, very heavy pedestrian traffic and crashes. And the speed limit range from 45 miles an hour to 50 miles an hour. The average speed was about the same, and then the 85th percentile was 55 and 60 miles an hour. We reduced the cycle lengths 20 to 30%. So that's reducing your green bands, it's increasing saturation, reducing pedestrian delay. They reduce the progression speed. So essentially, if you start traveling faster, you're going to start hitting red lights ahead of the signal timing. They added LPIs, 5-second LPI. And then it reduced total the amount of time in the cycle links. And then the north and south system still remained coordinated during the PM peak. So if you look at the black numbers are your original cycle length. The blue numbers on the bottom are your new cycles. So you went from 200 midday. You went from 200 seconds in the cycle length to 140 seconds. Start getting to early PM 200 to 160, and then late PM 140 seconds to 120. Just looking at the northbound. Travel time comparison is 3.6 miles. There's a travel time increase of 20 to 90 seconds depending on where you're at. So if you're looking at 3 miles, a minute and a half in the worst case scenario, it's a little bit, but I don't know that it's a significant change, my personal opinion. And then if you start looking at the level of service, your level of service in midday plan and PM peak did change. It went from a BC to a CD. Still not a significant jump, but it is still there. And then travel time reduction, 4 to 8 miles an hour, which is 7 to 15% travel speed. You got to think, in the grand scheme of things, 5 miles an hour increments make a big difference in terms of pedestrian survivability. And it still needs a good bit of data, but when we look at the initial conclusions, we're seeing that injury crashes are trending down pretty significantly. Total crashes a little bit. Fatal crashes, it looks like a trend down, but we're going to need more data time, more time looking at it to see if it really is or if it's just a bit of a bump. What I will say with this one, talking to Stephen Davis, who's the TSM&O engineer, they were not able to go as aggressive as they liked because the seasonal residents noticed the change, and they did receive a good bit of complaints. So that is one thing that they are working on is incremental step downs. They did this the first year. Their plan is to continue stepping down every year a little bit at a time until they finally get to where they want to be. But what he did say is that the initial time they tried it, even though this was the final timing plan, they were able to make a much bigger jump. It was just at that time too much for people to accept. So overall, we are still learning. There is still a lot of information that we're taking in. We're still trying to find better ways of doing it. But we have shown that it is effective when we do try. We've seen that there is a lot of opportunity for putting things on state roads that haven't traditionally been on state roads. And I think we can see that with the locals, design, traffic ops, and planning all working together, we do stand a really good chance of making the speed making speeds lower, and that making speed lower is one of the biggest cross-cutting and effective measures we can do. If we think about the safe system approach, it's one of the 5 main things. Safe speeds, right? Safe roads is a whole other thing. So speed is so important that it gets its own outside of safe roads. It is incredibly important in survivability. That equation of kinetic energy, 1/2 mass times velocity squared, speed is one of the largest determining factors. So with that, kind of want to wrap up. We could get a lot into speed, but we've got an hour and a half so far. Wanted to get an idea if anybody has any questions on what we've got right now. Lois was first.
Not so much a question as an observation, and I don't know if how prevalent this is across the state, but we have partners now that are very actively engaging in speed management. Palm Beach TPA is doing a speed management study, and it's not clear exactly how it's covering off system and on system. So we're And obviously state roads are part of the overall system, so we need to be part of those conversations, period. Broward MPO, they got a big Safe Streets for All grant, and they're working, part of that is a safe speeds action plan. So we have partners, and the extent, it's ultimately one transportation system, and increasingly our partners may have opinions about what are safe speeds on state roads. I don't know about that dynamic. It's good to have those conversations, particularly since those partners have resources. But anyway, I just throw that out there. And Metro Plan Orlando, we heard, did some sort of speed study focused on corridors. It was off system. I don't know how prevalent that is, and certainly something to have people be aware of.
Excellent. Lori?
I'll wait for the next person. Thanks.
I think Lois still had her hand up. You are the next person.
Oh, okay. So I have a wonder and then another question. So, I think this is the right context. I Googled saturation. It's basically like how many how many cars are on the road, like if it's flooded or if it's like, so I was wondering about the yielding, and I wonder how much of cars yielding in addition to speed is like if they have vehicles behind them, tailgating them, or the size of the vehicle, because I feel like that makes a difference in my own driver behavior when I yield. If I see somebody in my rearview mirror and I'm just not sure if they'll be able to slow down. And then my wonder is about how you said about in other countries, they may look at what are the safe speeds and determine the speed based on the road users. And I was thinking, oh, I wonder if we made our decisions on how big, like personal vehicles, how large they are or what their size is based on safety. I don't think that's why in some like maybe European countries they have smaller cars. I don't think that might be the reason why, but then again, could that be a part of the reason why? Because it's just safer?
All right. So I'm going to try to keep track of that. So the first question was about tailgating, I think aggressive driving, and whether that hurts people in speeds. I don't think, my answer to that is I don't think it's an isolated question. And that's usually behavior. I mean, obviously, I remember when I went to get my motorcycle license, they talked about, is like with a motorcycle, you kind of have to ride like everybody's trying to kill you. So one of the things that you do or you should do is increase your following distance a lot more than you would in a vehicle. Because if someone's tailgating you, like you can't really do anything about it. But what you can do is if you have a larger following distance, it gives you more time to slow down at a slower rate of speed. So as opposed to slamming on your brakes and getting rear-ended. With the saturation, though, I think it's a trade-off, right? Like the instance you're talking about can happen, but there's a big difference in how bad that is or how likely it is in a 45-mile-an-hour zone versus like a 30-mile-an-hour zone. So I think when we get into it as a whole, if we can keep lowering it, it makes a difference. There's going to be some people that are going to try to do ill-advised things no matter what. I was on A4 the other day, and you see the people that are weaving back and forth. No matter, it doesn't matter. They're getting 2 car lengths ahead, but they're going to try to cause 100 crashes while they're doing it. We can't design for those people. Those are the exceptions, but they're the ones that we remember. Like we don't remember that 98% of the people that were driving were doing exactly what they were supposed to. I have a theory too. I don't know if that's proven that increasing the platooning and the saturation can help with pedestrian safety. I'll address Ben's question in a minute. But I think as a whole, if you can slow people down, that starts to become mitigated. And then remind me what your second part was, because I think I've forgotten now.
Oh, just about the size of vehicles in other countries, if they're smaller, does that have anything to do with safety? Like their regulations on how
I think
it may
that's
be, yeah.
I think it's multifaceted as well, right? So there are regulations. I'm not as familiar with it. There are different regulations over there. One thing to consider too is like in Europe has a lot of older cities. So like if you're going to try to put a car through there, like you're not fitting an F-350. Like it's just not going to fit. There's some cultural aspects that are different. Europe does have different crash standards than we do. And then one of the things we talked about this, I think, earlier with vehicles that drove the larger sizes that we see today have been emission standards, where there was some emission standards released that certain size vehicles have to meet certain CO2 emission standards, but there was like a loophole that was left for larger vehicles. So it was easier to just make a larger vehicle than it was to meet the emission standards. So then everybody jacked the size of their vehicles up to meet that larger vehicle threshold. And then it just, I think, turned into something that everybody wanted to have at that point. It starts beginning, you start marketing and it gets into that loop where culture's involved. So I don't know there's a clean answer for that. I think there's a lot of pieces that go into the European car model. But we also allow it, right? Like AASHTO is changing their vehicle turning templates right now. So if you think about this, right, there's a certain turning radius and a turning template based on vehicles. Our roadways are designed off of that template. Everyone that's driving the road is successfully navigating that template. But we are going to be increasing the size of that template now. So it's going to be built out even more because the vehicles are larger. And that was done largely just on serving the larger vehicles. They can make the turns, but the analysis is done solely on the fact that this vehicle exists now. It's a certain percentage, and this is what its turning radius is. So it's an interesting relationship between some of the design standards and like how everything kind of folds together on that. Ben asked in the chat, it's physics, right? Motorcycles with two wheels on the pavement and less weight pressing down actually have less stopping friction than cars and trucks. They're more maneuverable, but can't stop on a dime. So cars and trucks also have more momentum. I don't know that I know the answer to that, but if you think cars and trucks are also trying to stop more at the same time. I had a friend that used to give me this problem. And I still don't know I think I know the answer to it, but it's kind of a physics problem, right? Because when you look at stopping power, you're looking at the coefficient of friction times the normal force, right? And which ends up turning into like a pounds per square inch conversation. So with a larger contact patch, that normal force is reduced. So when you see like drag racers that have really large tires, theoretically they should have the exact same gripping power as a bicycle tire. So then why do they use it? And I think the answer is gripping potential. Like as one part slips, because it's not a perfect surface, as one part slips, another grabs. But anyways, it's an interesting physics problem, because while there is, when you look at motorcycles, you have the coefficient of friction and a lower weight. That weight is also concentrated. You have more normal pressure, right? Because the same weight on 4 tires is going to be less than the same weight on 2 tires. So your normal pressure or your normal force is increased to a degree. But then at the same time, cars and trucks weighing more have a lot more that they have to do to slow down. So like my truck is, I don't know, I think it's 65 or 7,500 pounds. I have a heavy motorcycle because it was built in the 70s, and it's 550 pounds wet with all the fluids. So I mean, there's a big difference in what they're trying to stop. Interesting question though, Ben.
Yeah, no, my source on that it was Pat Brady from years and years ago, who frequently did these physics problems, but he may have been talking about this in the context of losing traction, explaining why a motorcycle would slip or would go down. So
the biggest, I mean, just it's kind of off topic, but the biggest issue a lot with the motorcycles is when you lose traction in one wheel, that's kind of it.
Yeah.
So with a car, if you lose traction, you're still on four wheels. Motorcycles can drift. There's a guy named Cody in MotoGP that's really good at it. But the problem is that you have to have friction in the front tire. When the rear tire starts to slide, the problem with that is that you have to be good enough to get back in line with the front tire before it gets traction again. Because if it's out to the side when you get traction, it's going to launch the motorcycle sideways in the opposite direction from the rear wheel, and that's where you get the high side crashes. The low side is management of friction. So braking, suspension, and just like side movement all take a certain friction from the motorcycle attraction value from the motorcycle, and you have a finite amount. So a lot of people too, when they're in corners, they start to hit on the brakes really hard, and that braking takes part of the amount of friction you have available to you. So a lot of times on motorcycles, while there are some advanced braking techniques that can do it, a lot of times the best thing if you went into a corner too fast is just lean more and pray, because chances are the bike can do more than what you are comfortable with. But they grab the brake anyway, and that's where you get the loss of friction, the low side crashes.